What's going on, YouTube? Just helping you out here. And for this video, I'm actually starting a new series, thanks to you guys. It's called Physics Help, and basically what I'm going to have is you guys requesting physics problems for me to do, and that you are having trouble with, or something doesn't make sense, and I'll be glad to help you out with that. So for the first problem today, it is, as you see in the diagram over there, it is a thin rod that is hinged to the top, and it's hinged like a ceiling or whatever, and it swings back and forth, and it's uniform mass, but it's like density is, its density doubles as it moves down the rod. So its density is 1 here and 2 here per se. So what we want to, and we're asked to find the moment of inertia about this point, and it is kind of weird because it is not a linear, it is not uniform density across the whole thing. So what we have to do is start with our fundamental equation: inertia equals mr squared. And so since our mass changes as we go down, since it's not the same density as the whole rod, we need to make this an integral of dm, which is like our change in mass, times r squared. And I'm going to denote r as x, just because I find that easier to do in an integral, just as far as keeping track of everything. And x is just how far down the rod we are. So this becomes inertia equals the integral, and our limit we're gonna call it 0, or 0 up here, either way, to L. So 0 to L of x squared, which is our r, just replacing it with x, times dm. Alright, but the issue is we're trying to find a change in mass, and here we have x. So we need to find a relationship with dm and x. So the thing is, we have this, since the density changes, what we're going to say rho, Greek letter rho, is equal to, which is the rho, which is the density of the whole thing, is equal to rho initial, which is, we're going to say, is the rho up top here, so our density at where the hinge is, plus x over L rho initial again. And what this is saying is we're going to have our initial rho, which is here at the end, plus some place on our rod, x over L, times the rho again. So basically what it is if our x is the same as L, so it's just 1 there, we get rho equals rho initial plus rho initial, which is just rho equals 2 rho initial, which is saying the rho here is equal to 2 rho here, so it makes sense. And then what we need to do is find our center of mass. So our mass, and we know that since the density doubles from here to here, we can say that the middle is 1.5. So our mass is 1.5 rho initial times our length. And we need to solve for rho initial, so we can say rho initial equals m over 1.5 L. I'm just rearranging this equation, solving for rho 0, and since we can't really have a decimal here, we can just multiply top and bottom by 2, and we get 2m over 3L. And then finally, to get our dm, dm is going to equal our density times change in x. So what this means is we have our change in mass, which is going to be equal to our density at a certain point on the rod. So we can rewrite this equation again as inertia is equal to the integral from 0 to L of, where we replace the dm, x squared, and our row here is the same as our row up here, so we can plug this in, and we get rho 0 plus x over L. Oop, I forgot another row in there. Rho 0 times dx. And then we can multiply that out. So it's the integral from 0 to L of x squared rho 0 plus x to the third over L rho 0 dx. And then we need to integrate. So that's going to equal, we'll just take out the rho 0. So rho 0, and then integrate x squared, which is x to the third over 3. And then integrate x to the third over L. L is just a constant, so we just leave that alone. And we get x to the fourth over 4L. We have to evaluate that from 0 to L. And when we do that, we get rho 0 times L to the third over 3 plus L to the fourth over 4L. And it's only that because if we plug in if we subtract the limit of 0, it's just going to be 0 plus 0, which this whole thing will be 0, so we can just actually neglect the 0 limit here. And so right here we have L to the fourth over 4L, so we can cross out an L here and an L here. And that's going to give us rho 0 times L to the third over 3 plus L to the third over 4, which we can then, if we find a common denominator, which is going to be 12, we get 4L to the third over 12 plus 3, 4L over 3L to the third over 12. And when we add those together, we get rho 0 times 7L to the third over 12. And our rho 0, which we solved for up here, is 2m over 3L. So what we can do is we can plug that in. We get 2m over 3L times 7L to the third over 12. And multiply those, we get 14mL to the third over 36L. So we can cross out an L in the denominator and an L up here, and we can reduce this to 7/18. So that's going to equal 7mL squared over 18, which is the inertia about the hinge. So that's it for this physics help. If you found this video helpful, please drop a like, leave a comment if you have an idea for a future video or a question about something I did. I would really love if you guys would request. That is what I want to make my channel. I want you guys to be telling me what to do, which will make my channel flow better, I believe. And so if you can help me out, and please subscribe and tell your friends about my channel so I can grow and help more people out. I'm just helping you out. See you in the next video.